So, good evening, everyone. I'm Narayan Rao. So, I'm actually going to talk about the product which we have, which is called SWASA, Artificial Intelligence Platform. Essentially, the platform helps in doing a respiratory assessment. Hello?
Yes, sir.
Yeah. The platform uh, addresses the problem related to screening of respiratory diseases in rural and remote areas, health centers. Using the platform, the respiratory assessment can be done in any of these health centers by just using a simple mobile phone application. So the health practitioner can download the application on his mobile phone, and as the citizen or the patient walks in into the center, he can collect a few symptoms information, and also can record the cough sound. Using the cough sound and the symptoms information, uh, what we provide is whether the person is having any kind of a respiratory problem. If he is having respiratory problem, what kind of problem is it? Is it more related to obstruction in the airways, or is it more related to the lung expansion problem? So essentially, the idea is that based on this information, health practitioner be in a position to recommend the patient to a next level of investigation, which can be like referring to a specialist or asking the patient to visit again. Uh, that's basically the problem which we are trying to solve. So let me demonstrate the application. It has two parts. One is a mobile application and another is a web dashboard. I'll start with the mobile application.
Sorry to interrupt, sir, but the screen isn't visible.
Yeah, I'm sharing right now. Till
Yeah.
now I
Okay.
did
Okay.
not. Yeah.
Oh, sure, sir. So sorry.
Can you see my screen?
Yes, sir. Now it's visible, sir.
Yeah. So as I mentioned, the demonstration has two parts. One is a mobile application and another is a web dashboard. So this is the mobile application. So any health worker or a health practitioner, can download this application. Once he downloads the application, he has to complete the basic registration details and all, by providing his mail ID, password, and some kind of a thing. After that, uh, he can actually do the assessment of for an existing patient ID, or he can also create a new patient. So here, I am giving an example of doing an assessment for a new patient. So, he enrolls the new patient where the patient ID, name, age, gender, that information will be collected. And after that information gets collected, yeah, these are the symptoms information the health practitioner will collect for that particular patient. Like does he has a frequent cough? Also, does he has a cough in the night? Is he having a sputum? Is he experiencing wheezing, and is he noticing shortness of breath, or any kind of a chest pain and so on? So this information he will collect it, and after that he will be recording a cough sound. So using the microphone, which is part of the mobile, the cough sound can be recorded. For example, yeah, here the cough sound is getting recorded. Is the audio, can you listen the audio? Hello?
No, sir. Your
No,
audio
sir.
is visible.
Yeah, I think, there is a way to make the, I don't know, in the WebEx, somewhere the audio need to be made. Yeah, I mean, I don't know. There has to be some way to use the computer audio. Uh, Anyhow, so essentially here, what is happening is that the user's cough sound is getting captured. For example, that's how the user records the cough sound. Once that cough sound gets recorded, the entire information, including the cough sound and as well as the symptoms data, will be submitted for the assessment. So the data goes to our cloud platform, which is actually running in AWS cloud, and within 10 seconds, less than 10 seconds, the user, the practitioner will be getting a response back. So for example, here the response says that based on the symptoms information and based on the cough sound collected, the patient is not having any kind of a problem, and everything is normal here. That's basically what the report is. And we can also provide a detailed report. There is the medical practitioner can get into a detailed report section, wherein he can actually select a particular patient ID, and he can actually generate a PDF file like what you are seeing here. This PDF file can be printed and it can be shared, through mail to a doctor or wherever it is required. So this report will have, the patient profile, like the patient ID, name, and so on. And then, based on the information we collected, the predictions from our platform, like as you have noticed earlier, for this particular patient, there is no respiratory problem and everything is normal. And also the characteristics of the signal. I mean, like, for how long the cough signal got recorded and how many wet coughs are there, how many dry coughs are there, that kind of information will also be provided. And the symptoms, like, the responses which he has provided as part of the assessment, for those questions which you had noticed. Okay, so this is the PDF form of a report which can be printed or which can be shared with the doctors as required. So this is basically the case for, and more importantly, in the current scenario, like, for example, not many of us are going to hospital. Am I right? We are now getting used to this home health and telehealth kind of a thing. So what happens is that we can do the assessment even at the home, and the entire information is available to the doctor. Like, for example, doctor can also play the sound, and he can listen to the sound. Did you get a chance to listen this time? Hello? Hello?
No, sir. No, sir. It wasn't audible.
Oh, okay. I think audio, again, as I mentioned, there may be a problem, but yeah. So the doctor can also play the sound at a later point of time. Now, in this particular case, this is a demonstration for a scenario where already there is an existing patient ID. And again, for the same, for the existing patient ID also, we will be collecting this kind of an information. And then the cough sound gets recorded and the entire information will be submitted for the assessment. So, here, basically, based on the information what we collected, uh, we are able to detect that the person is having an underlying respiratory problem, which is actually a restrictive disease with a low severity. And so earlier case it was normal, but in this case the person has a problem. All this we could identify, based on the cough sound we collected and also the symptoms information which is provided. So in the background, when we are sending this information to our platform, Swasa platform, which is running in the AWS cloud, we are actually using artificial intelligence to kind of like process the. I mean, initially it all starts with the signal processing, basic signal processing, like removing the noise and extracting events from the audio file, and removing all non-cough events and only taking cough events, and then subjecting those cough events for the real assessment. So for the assessment, we use machine learning and artificial intelligence to really identify the underlying pattern, and based on that, we will be providing this kind of an output. Okay, so again, here the doctor can get into the detailed report where he can see the the PDF file. As you can see here, our prediction is saying that there is an underlying respiratory problem with a low severity and it's a restrictive pattern, and he can also see the signal characteristics and symptoms. So basically, this is the one part of the demo, which is a mobile application. As I mentioned, the medical practitioner or the health worker will be downloading this application onto his mobile phone. Once he completes his registration, he can actually enroll patients. He can enroll a new patient, or he can already select an existing patient. For each of the patients, he can do assessment, and for doing an assessment, all that what he requires is few symptoms information and recording of the cough sound. Maximum 10 seconds record is required, in which we can have multiple coughs, which will help in detecting the underlying problem. So in case if you are familiar with the spirometry, which is actually the gold standard for conducting the lung health check, spirometry is based on the airflow characteristics, and whereas our technology is based on the audiometric analysis. But the output what we provide in terms of whether there is an airway disorder or there is a lung disorder, is actually functionality wise it is exactly same as what spirometry does. So in that way, we are a substitute to spirometry. Wherever there is no spirometry, our application can be very much useful. So with this, let me move to the other part of the demo, which is actually a web dashboard. So this is the web. Can you see the web dashboard? Hello? Hello?
Yes, sir.
Yeah. So this is a web dashboard. Yeah, this is basically a web dashboard. Here, what say for example, a health practitioner who is responsible for managing a particular health center. Once he logs in into this dashboard, he will be able to see how many patients are scanned using this particular tool, and how many of them are currently at high risk, and how many assessments are they doing on an average. And more importantly, he can actually look at how the trend is moving on a week on week basis. For example, in the context of a COVID, say, how is the risk trend, is it decreasing or is it increasing? That kind of analysis visibility he will have. And he can also see, at a given point of time, how many people are under high risk, how many people are under low risk and medium risk. This kind of information he will be able to see. This is what we call as a population view. Okay, and from here he can get onto an individual patient centric view. Here you can see, these are the number of patients. For example, I can select a particular patient, and I can actually see the details about the latest assessment, what the patient has done. For example, in this particular case, the patient by name no, Lakshmi Narayana, based on the information which we collected, the assessment, in a score of 1 to 10, he is currently at 8, which is actually a very high risk. So, you can actually see the symptoms information which he has provided when the assessment got done. And, the health practitioner can look at the indications which the platform has provided, like, underlying respiratory condition, what kind of a pattern is it. And then he can also look at the characteristics, like the cough duration, number of dry coughs and wet coughs. All this kind of information he will be able to see. And more importantly, of course, he can also play the cough sound which got recorded. Okay, and more importantly, he will be able to have a longitudinal view. What does that mean is that, for example, for this particular patient, how is the risk trend over a period of time? As you can see here, the risk is increased in the last few days. And similarly, how, for example, how is the body temperature? Is it as you can see here, body temperature also increased recently, which has direct correlation to the risk. And you can also notice like the change in wet cough and the dry cough count. How the count is varying during morning, afternoon, evening, and night. This kind of an information a health practitioner can have. This is a very detailed information. Each point on this graph is really like one test. So the patient has done one assessment, and like that, he has done multiple assessments. So using those multiple assessments, this temporal view is provided. So the important information which it carries is that, say for example, if there is an increasing trend, like the dry cough count, as you can see here, it is actually increasing, which is a cause of concern. So the moment it crosses a threshold, an alarm can also be generated, and the alarm can go to the patient and as well as to the doctor. Similarly, you can notice the wet cough count variation as well. Okay. So, like as I mentioned, each data point is an assessment. So, if a medical practitioner want to go back to a particular test report, he can actually go to that report and he can look at the symptoms information what patient has provided. You can look at the indications, like what are the indications from our platform and characteristics of the sound and so on kind of thing. So this is basically a detailed patient view. So the health practitioner has some two views. One is what we call it as a population view, where he will have visibility about total number of people and how the risk trend is varying across the the individuals. And then a patient centric view, where he can get into a particular patient and look at the details, like the number of assessments he has done and the characteristic variation and so on kind of. So this is basically what I have to demo. As I mentioned, there are two parts. One is the mobile application and another is the dashboard. Yeah, I mean, I'm done with the demo. We can actually take any questions you may have. Hello?
Yes, sir. Thank you. Thank you. 1 second. We don't have any questions as of now, sir. Uh,
Hello.
Yeah, hello. Hello. Am I
Sir.
audible? Yeah, madam.
Hello.
yes,
Hello.
ma'am. Hello.
Darshan.
We don't have any questions. Can you please present the Momento screen? Thank you for the project demonstration, sir. The product you've shown, Swasa, is really inspiring. And in these pandemic times where we can't really go to hospitals, the self-assessment type where your project works is really helpful for all people. And we really thank you for presenting. We have a virtual memento to as a token of gratitude.
Sure. Thank you.
Yes.
Wait,
Um,
sir. Wait 1 second.
Yeah,
Yes,
yeah,
ma'am.
no problem.
Oh, share option is disabled for me.
Okay, then let me. Uh, uh, can I come out of share? I don't know. I don't have. You only need to make me unshare.
Wait, sir. Wait 1 second.
No problem.
Sir, are you able to see that?
Yeah, I can see it now. Yes. Thank you, madam.
Sir, please switch on your video once. We will take one
Photo.
photo.
Yeah, I switched it on. Let me put my spectacles. You can take photo also, is it?
Actually, I am taking screenshot, sir,
Oh, okay.
but I don't know how to do that. Photo. Okay, thank you, sir, for.
Thank you. No problem. Thank you, madam. Bye.
Thank you, sir. Thank you, sir.
Thank you. Yeah. Bye.
Darshan, Ramesh? Ramesh,
Ma'am,
are you there?
yes, ma'am.
Darshan?
Yes, ma'am. I'm ready. So we have the third and the final demonstration of today. It is by Mr. D. Ramesh Reddy. Mr. Hello? Yeah. Mr. D. Ramesh Reddy is currently working as an assistant professor at Vignana VJIT in the Department of Electronics and Communication Engineering. He has a total of 7 years of experience comprising of 3 years in teaching and 4 years in research. Sir has guided more than 20 graduate students and 10 uh, undergraduate, 20 undergraduate and 10 graduate students. His research areas of interest in embedded systems applications. Mr. Ramesh has also published papers titled Water Quality Measurement Using Hybrid Sensors and Water Quality Monitoring and Controlling in Irrigation Using Zigbee Technologies in reviewed journals such as IJSR and IJSETR. He has also presented papers at IEEE international conferences on computing, communication, and sensor networks. Mr. Ramesh has worked on research projects like mobile image position and performance acquisition systems and development of effective wireless sensor network systems for water quality and quality monitoring, that is Aquasense. So we are really pleased to have you here, sir. Please proceed with the demonstration.
Yeah, thank you, Darshan, for your lovely introduction. Good evening to all the participants. And can you give this? I am unable to share my screen.
Ramesh, is it working now? Hello?
Yes, ma'am.
Are you able to present?
Yes, ma'am. Ma'am, can you see my screen now?
No, sir, it isn't visible yet.
Now is it visible?
Yes, it's visible, sir.
Yeah. Yeah. So myself, Ramesh Reddy, Assistant Professor, Department of ECE from Vignana, Jyothi, and I am pursuing my PhD at NIT Warangal. So today I am here to discuss few of the development boards which are regularly used in the Internet of Things. Okay. So today we will discuss different IoT boards like Arduino board. We are going to interface few sensors like DHT sensor to the Arduino, and we are going to interface the humidity and temperature sensors to Node MCU, and also we are going to interface DHT sensor to Raspberry Pi also. So we are going to see these three demos for today regarding our IoT boards. So to start with, these are the boards which we are going to see today. That is Arduino board, Raspberry Pi board, Intel Galileo, and also Node MCU and Arduino Mega. So now today I will discuss more on Arduino, Raspberry Pi, a Node MCU. So we are going to interface few sensors to this IoT boards, and we are going to see how these actually the sensor data is collected, and the collected data is stored in the cloud platform. Okay, to start with Arduino, so this is an Arduino board which has an Atmega 328 microcontroller, and it is around 28 pin microcontroller, where we have 5 analog pins where the few analog sensors can be connected, and we have around 13 digital general purpose input and output pins where we can connect different input and output devices. And we have a serial programmer where we can program using our laptop. We have a DC volt regulator with regulator, and we can connect around 6 to 24 volts of DC voltage that will power our Atmega 328 microcontroller. Okay, so this is a board with a microcontroller, that is Atmega 328, and we can see the different parts of our Arduino board. So we have a reset button where we can reset. That means the program, whatever program we have dumped in Atmega 328, that will be started from the first instruction. And we have a transmitter and receiver LED. So whenever we are transmitting the data serially, then these LED indicates the transmission, and the receiver LED indicates the reception. And we have several digital pins to connect digital sensors. We have power LED. Whenever we power, the LED gets on over here. The yellow is a power LED. And we have an Atmega 328 microcontroller which can be removed, and it can be replaced with another Atmega 328 microcontrollers. And we have 5 analog I/O pins where analog sensors can be interfaced. And our Atmega 328 microcontroller on Arduino board can convert it has an inbuilt ADC which converts these analog signals into digital values. And we have power pins to connect to the external sensors, and we have a 3.3 voltage regulator. Whenever we connect DC voltage of 6 to 24 volts, we have a regulator which converts 3.3 volts, because our Atmega 328 only works on 3.3 volts. Okay, and it has a crystal of 16 megahertz, and we have an USB to serial IC converter where we are programming this Arduino board using an Arduino IDE which is in a laptop. That program can be dumped using this USB to serial IC. Okay. So this is just some the board of Arduino. Now coming to the programming Arduino. So we have an Arduino IDE where you can Google it Arduino. Then you will have an Arduino home. There you can go to the Arduino website, and in the Arduino website you can have a software. From that software you can download the Arduino IDE. Integrated development environment which is used to program our microcontroller, that is IoT board, that is an Arduino microcontroller. Okay, so if you are if you are programming using a Windows, you can have a Windows installer. If you are using Linux systems, you can have a Linux IDE, and if you have an Apple, you can have a Mac OS IDE. So you can download this IDE, and so whenever you download this IDE, whenever you connect this board to the computer, then you can go to the device manager and you can see whether our board is connected to the serial port of a laptop or not. So here on the left side, I have not connected any devices. On the right side, you can see the USB serial device which is connected to the COM4. That means my Arduino is connected to the COM4 of our laptop. So whenever before you program Arduino, you connect to your PC and go to device manager. In the ports, you can see the port enabled for Arduino. That you can see on the IDE also. Okay, so this is a sketch which we can use. This is used to program our Arduino board. Let me show you the IDE and program the Arduino. So I have already installed the Arduino IDE in my laptop that I'm going to open it and show you how exactly we are going to program these boards. Can you see the IDE? Darshan, is it visible?
Yes, sir, it's visible, sir.
Yeah, so this is what an Arduino IDE is like. See, whenever you open, you will have a void setup and also a void loop for the new sketch. So whatever program you want to program the microcontroller, so you need to program in the void loop, which is infinite loop, and what are the instructions you want to define, that you will define in the void setup. So you go to file, whenever you press new, so you are ready to program a new sketch in Arduino. So if you want, so if you are very new to the microcontroller and you are not that much familiar with the IDE, then you will have few examples for you in the file example section. We have basics. See, we have basics. In the basics, we have how to read an analog read. We have a blink, that means LED blinking. We have how to read a digital reads, how to read the serial digital, and we have how to read the analog voltage also. So in the basics part, you have these things, and in the digital part, you have an interface. Interfacing a button, you have an interfacing debones of a button, you have a melody part in the see, whenever you connect a speaker, you can generate melodies using this tone melody. So like when you're working with analog sensors, you will have analog in out serial, you will have analog input, that means you are taking the input, you will have the calibration, fading and smoothing. So whenever you are working for the serial communication, you have see all these programs already there in your the file example section. So I will just demonstrate you a blink program using this Arduino IDE. See, coming to this, we have a void setup and we have a void loop. See, all the initializations will take place in the void setup, and the program which is going to be infinitely run, that is made available in the void loop. See here. I have an inbuilt LED which is connected to the 13th pin of Arduino. Then I want to make that, see, my LED is an output device. So that 13th pin, I am making it as an output. Okay, so LED built-in means I can write this LED built-in means it is connected to the 13th pin. Okay, so pin mode, I am changing the mode of 13th pin to output because I have connected LED, that is an output to a general purpose input output pin, that is 13th pin. Okay, suppose if I am connecting a switch, that is an input. If I am connecting a switch to 13th pin, then I will make the mode of the general purpose input and output pin of 13 as input. Okay, so because I am using an LED here, so I am connecting, I am making it as an output. Okay, so this is what the initialization of LED, that is an output to the 13th pin. And coming to this, the blink program, that means I am going to turn on the LED which is connected on the 13th pin for 1 second, and I am going to be in that state for 1 second, and I am going to turn off the LED for 1 second. This is what blinks. So I am running this infinitely. That means what? So it will run for 1 second and it will turn off for 1 second. So so this delay is a function with the input of 1000. Here 1000 refers to 1 second. So if I want 2 seconds, I will make this as 2000. If I want 5 seconds, I can make this as 5000. So first thing is, see here, you should check the board. So go to tools, check the board. See, I have connected a node MCU to it. So I will change this. Now I have connected Arduino Uno. So I will change the board to Arduino Uno. Then immediately you will get Arduino Uno on the bottom right side, Arduino Uno on COM3. And one more thing, I need to check with the port. See here, here Arduino Uno is on COM3, but actually the port is connected to the COM4. So if I run like this, if I compile and upload this, so my Arduino is connected to Uno 4, but you have selected COM3, then this will not work. That means the program will not upload into the microcontroller. So what I need to do, I need to go to the tools, I need to go to the port and select COM4. See, immediately the Arduino Uno is changed to the COM4. Now I will verify the program. See if I have done any mistakes, that you will compile the program and you will see if there are any mistakes. If there are no mistakes, it says done compiling. If there are mistakes in any piece of code, then it will show on the bottom, like line 12, semicolon is missing or it is not defined. Okay, it will show like that. So I'm compiling the program. So it says done compiling and I don't have any errors over it. Okay, suppose I change this, I forgot to enter pin, P in pin mode. See, I'm compiling it and it will say that there is an error in defining an LED pin, see, where in mode was not declared in this scope. So it straight away says the line and where exactly you have done the mistake. See, it is pointing out this line, you have some mistake. Okay, so I'm going to correct it and I am again going to compile it. Okay, done compiling, and after that you upload it. Okay, so whenever you upload, again it will compile and again it will upload. This piece of code is through serial port, we are going to dump into this microcontroller which is present on Arduino board, that is Atmega 328. So it says done compiling. See, the LED which is present on the 13th pin is blinking for every second. Okay, now if I want to blink this for every 5 seconds, then I will make this as 5. So I am going to turn on the LED, that is built-in LED, that is 13th pin for 5 seconds, and I am going to turn off for 5 seconds. So you have changed the code, you can again upload it. See, the LED is turned on for 5 seconds and it is turned off for 5 seconds. So this is how we program the basic Arduino microcontroller. So our Arduino IDE, which is used to program this microcontroller. Now we will see how do we interface a sensor to this Arduino and how do we see the output in a computer. Okay, that is what we will see. Now we will move on to the presentation. I will show you all these things. Yeah, so we have seen this blinking an LED. So we have selected the port. The first thing you should keep in mind, you should select the correct port. Okay, so the COM4 which is selected, which Arduino is connected to the laptop, and there you will compile it and you will upload the program. Okay, now moving on to the temperature and humidity sensor. So this is what a temperature and humidity sensor, DHT11, which temperature as well as humidity sensor. Okay, this is a digital sensor where it requires a library, DHT library that need to be installed in the Arduino to connect to the Arduino and see the temperature and humidity of this room right now. Okay. Now, so coming to the interfacing part of humidity and temperature sensor, so we have connected, so we have altogether three pins on sensor. That is, we have a power supply, we have a ground, and we have a data. So being this as a digital sensor, so I'm connecting this to a digital input. Okay, I will make this third pin as a digital input and I will collect the data from the sensor and I am going to show you the value of this temperature, value of the temperature in room and also the humidity in the room. Okay, this is what the DHT11 sensor is. Okay, so this is what code is. I will show you the code and I will run the code and I will show you the temperature and humidity of this room. Okay, we have we need to include the library. I will show you how to include the library. See, I'm opening the Arduino IDE and I'm going to interface this the three pins of DHT sensor. The positive pin that is connected to the 5 volts pin of Arduino and the ground pin that I'm going to connect to the ground pin of Arduino, and these I'm going to connect to the second pin of Arduino. So I'm interfacing the sensors to this Arduino. Okay, so you see here, I have included a DHT library. I will show you how to include libraries in Arduino. See, you can go to Sketch and include library, add zip library. See, you can Google the DHT library in Google and you can download the zip library and directly you can install by clicking add zip folder. Okay, so I can, if I have a DHT over here, I can include right away, or else you will have manage libraries. There you can type the library and you can install on the go. So that also I will show you. I have already installed the library in the Arduino IDE. That means it will show that it's already installed. So if you are working on these libraries, then you type here. See, suppose I am working on DHT sensor. Okay, I am typing DHT11. See here, DHT sensor library is already installed over here. Okay, so it is installed. So if it is not installed, you can just click on the install button over here. So I am going to install DHT library for ESP. Suppose if you think I want to install this. Okay, so I can directly straight away say install. That it automatically installs. Okay, it automatically installs and it updates the Arduino IDE. Okay, so we are including the DHT library using you can go to the Sketch, you can include the library. Okay, So this is without the library, this piece of code will not run. Okay, see, I will explain you the code now. So I am including the DHT library. Now I am connecting the DHT pin, that is the output pin of the sensor. I have connected to the second pin. Suppose you want to connect to the third pin, you can keep it as third pin. Okay, so you have around 13 digital pins where you can connect to any one of the pins. And see, in the library, it has mentioned that whether you are using DHT11, DHT22 or DHT21. So we are using DHT11. So I have connected, I have uncommented the DHT11. Suppose I am using DHT22, then I will uncomment this. Okay. So this is DHT pin, that is 2, and it is type. So this I am giving DHT11 a second pin and DHT11 to this DHT line. Okay. So one more thing. See, this Arduino doesn't have an LCD to see the output. So how can you see the output? Now we have a serial monitor. See, on the right side, on the top corner of right side, you have a serial monitor. Okay, so you can print the value of the sensor to the serial monitor and you can see whether I am getting the sensor data or not. Okay, so if this serial monitor is not there, then what you should do, you should externally connect an LCD or an LED. Whenever the sensor data is received, then you need to so send the data to the LCD and then you can see. So our Arduino IDE provides a serial monitor which is going to continuously sense the data of the sensor and it is going to display in the serial terminal. Okay, so in the void loop, I am going to read the humidity, temperature. See here, the temperature as Celsius. I am going to read. See, I am going to use function dht.read humidity. So straight away it will read the humidity and that is converted into float. Okay, and also I want to read the temperature in degree in Celsius and also in Fahrenheit. Okay, so I have these two options to select in degree centigrade or in Fahrenheit. Okay, so I'm sensing the data from the sensor. Now I want to push the data to the serial monitor. See, so I want see if you want to push the data to the serial monitor, then you should give serial begin with the baud rate 9600 or you can give 4800 or any baud rate. Okay, so preferably it should be 9600. Okay, so whenever I print serial println starting DHT sensor, this data is pushed to the serial monitor and that will be printed onto the serial monitor. Okay, so I am printing the IEEE SPS Summer School. I am printing the humidity value. I am printing the temperature value in degree centigrade and Fahrenheit, and also I am giving the heat index. Okay, so now what we will do, we will just check whether the Arduino board is connected to the COM4. Yes, it is connected, and yes. Whether I'm using the Arduino board, yes, the board I have selected Arduino Uno, then you need to compile the script. Okay, you need to compile the code. So if we compile the code, if you have any issues in the code, it says there is an error in that line. Okay, so we will see it says done compiling. That means there are no errors over here. So after compiling, what we will do, we will upload the code into the Arduino board. See here, see already the LED blinking code which is present in the Arduino that is running over here. See, I am powering this using USB cable. So Arduino is getting a power from the USB cable and the LED is blinking. That means what? I have ported the LED blinking code into the Atmega 328. So that is why it is running. Now, if I upload this code, that piece of code will be erased and this piece of code will be dumped onto the microcontroller. So likewise, you can do n number of times, you can erase n number of times in the Arduino board. Okay, so it says done compiling and now I am going to upload the sensor value. I am uploading the code to the Atmega 328 microcontroller. So whenever upload takes place, the serial the serial LEDs will start glowing. That means there is a serial communication between the laptop and also the Arduino board. See, whatever code I am writing in a high-level language, the Arduino IDE converts that high-level language into the machine understandable, that is the microcontroller understandable language, and that hexa code is dumped onto the microcontroller. So it is taking time to upload. We'll wait for 2 minutes and let it upload. Okay, there is an error in uploading the code. Maybe the serial port has been, yes, I'm taking out the board and I am again see. We'll check with the port. Yes, it is connected to the COM port. We will verify with the device manager whether it is connected correctly or not. So you can go to the device manager and see to which port our Arduino is connected. See, compiling it will do because the compiling part will takes place in the IDE. So yes, our Arduino Uno is connected to COM4. It's okay with that, and let me upload it and once check. Yes. So it says done uploading. That means it successfully ported the code, piece of code which we have written in the Arduino IDE into the microcontroller. Then in the serial port, you can see, see there we have selected baud rate as 9600. Then you should choose select 9600. So it is going to start reading the sensor. See, so the humidity is 57% and the temperature here is 27 degrees centigrade and it is converted into 80 degrees Fahrenheit. Okay, so this is what we are connecting a sensors to Arduino microcontroller and we are checking the real-time values of the data in the serial monitor. Okay. So for every fraction of a second, we are calculating the value. Then you can increase the delay here over here, and you can collect the data. So this is what an interfacing a DHT sensor to the Arduino. Okay. So moving on to our presentation. Yes, we have seen interfacing. We have completed, we have successfully interfaced an DHT sensor to the Arduino. Next we will see the node MCU. Okay. So as I told you that we will see today Arduino, Node MCU and Raspberry Pi. So this is a Node MCU. See what is the basic difference between the Arduino and Node MCU is this is the same microcontroller is present in the Node MCU also, but Arduino doesn't have an IoT an enabled IoT which is enabled Wi-Fi which we need to connect to the cloud. Yes or no? So straight away in an Arduino we are seeing the data in a serial monitor. Now, the Arduino plus Wi-Fi, we call it as a node MCU. Okay, so in this node MCU, we can connect to the Wi-Fi router which is nearby, and we are going to sense the data from the DHT sensor, and that sensor data we are going to push the data to the cloud, and we are going to verify the data in the cloud. And we can collect the data for every 1 minute, and that data we can analysis using a cloud platform. Okay, so we will see the node MCU installation part. Okay, this is what I'm interfacing the DHT sensors to the node MCU. See here, this is an Atmega microcontroller with Wi-Fi built in. Okay, and also we can make Arduino also Wi-Fi enable using ESP32 or ESP8266. It is an Wi-Fi model. That Wi-Fi model we can install to the Arduino, and we can enable Arduino is a IoT device. The same thing they have integrated onto a single IC, and they have made as a node MCU. So now I am interfacing the same sensor, that is DHT sensor, that is temperature and humidity, to a node MCU, and I will show you the programming part and also the demonstration part. Okay, so the same thing, the library, the DHT library is the same thing. We need to have, see, once you have done with the DHT library in Arduino IDE, that means the same IDE we are going to use for node MCU also. Okay. And the few of the things we need to change in the node MCU, that is, we need to have a sensor library that are say DHT11 is Adafruit unified library. So we need to install that Adafruit unified sensor library for Arduino. And see here, and one more thing, that Arduino IDE is meant for Arduino. Now, if you want to use the same Arduino IDE for Node MCU, then you should have some settings need to be done in an Arduino IDE in order to work with Node MCU. Okay, I am going to show this those settings. See, in the Arduino IDE, you can go to File, you can go to Preferences, and there in the Preferences, you need to copy this and you need to paste over here. Okay, that means what? Our Arduino IDE that need to be supported for the ESP8266. Instead of having another IDE, we can use the same Arduino IDE. Why I have explained you the Arduino board initially is this Arduino IDE is a universal IDE for all the boards. Okay, you take Arduino board, it will work. You take Node MCU board, it will work. See, you take Intel Galileo board, it will work. So I will show you what all the boards it will work. Okay, so that if the node MCU need to be worked in the Arduino IDE, in the preferences we need to give this package, that 8266 package, into this additional board manage URL. Okay, that URL we are going to provide over here. Next, in the board we are going to select node MCU. Okay, so and also we are going to install the Wi-Fi package ESP8266. See, the same way how we have installed the DHT11 sensor library, the same way you can install ESP8266 also here. Okay, and finally we are going to select node MCU over here. Okay, and we are including the library Arduino JSON master. Okay, so these libraries we will include. Okay, practical I will show you how to do all these things. Okay, so we are done with the Arduino now. Okay, before I explain you the piece of code, I will show you. See here. See, the board here I connected is node MCU. See here, tools, board. You need to select node MCU because right now I am going to work with the node MCU. Okay, our Arduino IDE is going to work for all these boards: Arduino Mega, Arduino Leonardo, LilyPad, DigiSpark boards, ESP8266 boards, and Intel Galileo boards. See, you can go to board manager, and in the board manager, see, if you want to work with the Intel Galileo board, then you can straight away type over here Intel Galileo. Okay, see, Intel boards. So you will install this board. Then whenever you install, then only you can work on these boards. Then that boards will be shown in this board. So then you will select Intel Galileo and you work on with Intel Galileo. Now I am working with the node MCU. Then I will select node MCU. Okay. So in the down on the bottom you can see the node MCU. Okay, node MCU. Okay, so I have done with the node MCU. So here one more thing, that data which we are getting from the sensor, we are pushing this data to we are pushing this data to the cloud. So here I am using ThingSpeak Cloud. Okay, so this is what ThingSpeak Cloud is. Okay, so you can just type thingspeak.com. There you can go, you can just sign in. Okay, give your email ID and you can create your own password and you can create your own channels. Okay, so here I have created a few channels over here. So this Arduino channel is for our Node MCU. Okay, so we are collecting the data from I think we have started at 5:47 and I think we have ended at 6:07. So okay, one thing I will delete this data. So I am clearing the channel. That means whatever the data previously that was there in the channel, I am going to clear that. Okay, so you can just view this. Yes, so there is no data now. Okay, so this is a channel that need to be created. See, I am going to send the humidity and temperature data to the ThingSpeak. Then I need to have a chart for temperature and also for a, we have two fields. One is temperature field and another is humidity field. Okay, so that temperature field I need to create, and if see, suppose I am giving the light value also, then you can add one more field over here. One more thing you should take care of it is, see this API keys. Okay, so we need to have this API key in our program in order to write to this channel. Okay, so we need to have this API request. This API request. Suppose I am reading from the channel, then you will have read API. Suppose I am writing to the channel, into the ThingSpeak channel, that is cloud platform, I should have a write API. Okay, so you please copy this write API and we need to keep that over here, API. Okay, and I am connecting to the nearby Wi-Fi router, that is WP, and its password. I need to mention its password also. Okay, so that my board will be connected to the Wi-Fi and that is linked to the ThingSpeak channel, and I am going to get the data from the see, I am going to get the data from the DHT library, and that data I am going to push to the ThingSpeak using API key. See here, the host here is API thingspeak.com. Okay, I am using HTTP request. Okay, that request I am going to send to the write API. Okay, and I am after sending the data, I am going to stop. Okay, so I am going to connect this to my laptop. Okay, so I have connected this. So whenever you connect these boards, please verify with the device manager. Okay. If you don't have drivers for this boards, then this port is not enabled in this device manager. Then you need to install these drivers. Okay, so the, here I am see this board is using Silicon Labs, that is which is connected to the COM3. See here, this board is connected to the COM3. See, if I remove this, see I have removed from the USB, and you can see there are no ports enabled over here. See, and again I am connecting to it. And you can see the port enabled here. Okay, so that is connected to the COM3, but see here I have given to the COM4. See, if I write this code into this node MCU, it will not write. Okay, so then what you need to do, we need to go to the port, connect to the COM3. See here, node MCU is connected to COM3. Now what we need to do, we need to compile the program. We need to compile this program. So if there are no errors over here, it says done compiling. Then after that, what we will do, we will upload the piece of code to the this IoT board, node MCU board. So this board is connected to the nearby Wi-Fi, and from that Wi-Fi we are pushing this data, that is temperature and humidity data, to the cloud. Okay, suppose I am powering this and I am keeping somewhere in my college, and that data I can visualize from my home also. So likewise, you have n number of applications. See, you can monitor the temperature of your room. You can control the ACs. You can control your refrigerator. You can control your AC. So with this, we will have, we can set the temperature also by connecting an external relay. So it is taking time. Let's wait for it. So after compiling, we will upload the code. So after uploading the code, what it will do, it gets the data from the sensor, and that data is pushed to the write API key to the ThingSpeak channel. Okay, that channel which we have created. So I am uploading it. Okay, it says uploading. See here, 7%. So it says the percentage of it shows the percentage of uploading also. So whenever it finishes, it says you can hard reset. Okay, see, so that means it has successfully uploaded this piece of code to the node MCU. Then what we need to do, we need to go to the channels, that is my channel, and I have created that channel in the Arduino. Okay, and see here, so the data. Okay, at 8:15, at 8:16, okay, I'm getting the data. This is the temperature data and this is the humidity data. So if I give you this channel link to you, okay, then you can also see the data. Okay, so if I make this as a public view, see if I make this as a public view and share that link to you, okay, then you can directly see the temperature and humidity value of my room now here in from VNR Vignana Jyothi. Okay, you can see the values. So you can see there is there is see at 8:17 it's around 28.86 degrees centigrade, and see because I am keeping near my mouth and I am talking, so some sort of temperature is generated to the sensor. See if I blow my air, if I blow hot air, then see the temperature will increase. See the temperature is 29.8 at 8:17 at 41 seconds. Let's see. See, the temperature has increased to 30. So you are measuring the real-time data, that is accurate data. Yes or no? Okay. So the humidity is same because there is no. See, the temperature is slowly moving on. See, from 29 to 30, from 30 to 31. Okay. So this is what an IoT device, a small device, okay, which is not the size of my finger. Okay, we can connect to a sensor and a small battery. We can throw somewhere, and that is connected to a nearby Wi-Fi, and we can collect the data for every 1 minute. See, it's less than, I think. See, at 2018, I got the data. See, I have moved my sensor. See, the temperature has reduced from 31 to 30.4. Slowly, gradually, it decreases the temperature. Okay. So this is what the demonstration of IoT node MCU IoT board. Okay. And slowly we will move on to the next topic. Okay, so I will show you how to create the ThingSpeak cloud platform in the Raspberry Pi session. Okay, I'm removing it. Okay, So now coming on to the another IoT board, that is Raspberry Pi. The same sensor we will interface to the Raspberry Pi, and we will send the data to the ThingSpeak cloud, and we will see. Okay, see, Raspberry Pi is a small credit card sized mini computer where you will have a HDMI port, you will have a audio jack, we will have a a small camera slot, and you will have a 32 to 64 GB of memory slot, and you will have 4 USB ports, and you will have an Ethernet port. See, everything you have. It's like computer. See, Raspberry Pi 4 has 8 GB of RAM. Okay, it's like mini computer. Okay, so if you want to see the data, we will externally connect to a display, or we can connect through LAN. Okay, so you need not have carry the display all the time. Okay, we can connect to we can just connect Raspberry Pi to the nearby Wi-Fi or a LAN connection, and from here we can directly log into the Raspberry Pi and check what is happening in the Raspberry Pi. Okay, it's like a mini computer. Okay, so we will see how to interface this DHT sensor to the Raspberry Pi. As we have seen the ThingSpeak open source IoT platform over there. So these are the steps. How do you create a channel in a ThingSpeak? See, in the Google, you type ThingSpeak. Okay, you give your email ID and password. Okay, you create your new channels, and in the new channel you can create your own fields. Like, see, suppose I am measuring the humidity and temperature value. I have created 2 fields, and I am creating if I am measuring the light value of also, then I can have a field 3. Likewise, you will have around 8 fields in your one channel. Okay, these are the okay. So you will have a write API. We will see this. Okay, I have connected this. This is a Raspberry Pi board. Okay, this is the sensor which I am connected to the Raspberry Pi board, and I have connected this Raspberry Pi through LAN connection. Okay, so this is a Raspberry Pi 3 which has an inbuilt Wi-Fi also. Okay, you can. I will show you that the Wi-Fi also. It will connect to the Wi-Fi also. Okay, we will move on to this cloud platform. Anyway, we have seen. Now we will move on to the practical section of Raspberry Pi. So what I am doing now here is, see, I am connecting the Raspberry Pi to my LAN, and here I am using a VNC viewer through which I will go to the Raspberry Pi, and I'm connecting through LAN. So I need not have a display over here. What's the IP? Okay, 0.5. So with that IP, I am going to connect to the Raspberry Pi. We'll wait for 1 minute. I think there is a network. Okay. See, I have to connect to the same Wi-Fi. Let me check I have connected to the Wi-Fi or not. Oh, I am not connected to the Wi-Fi. Okay, I need to connect to the same Wi-Fi. I think I have connected. remove cheyna. The password. See, why it is not connected is I have connected through the LAN, but the Raspberry Pi is connected through Wi-Fi router of the other Wi-Fi router. So now I need to connect to the same Wi-Fi router. Okay, so because the IP will change over here. Okay, so this is our Raspberry Pi. Okay, so it's like it's similar to our computer. Okay, see here, this is a screen of a Raspberry Pi. It's not my screen. Okay, so here you will have a terminal. So it's like the Linux flavor. Okay. See, I am working on Raspberry Pi using my laptop. So there is no requirement of external keyboard or mouse or a display connected to the Raspberry Pi. See, if I keep somewhere to that, if I know the IP address of it, I can straight away connect from my laptop by sitting anywhere in the world. Okay. So I think you are familiar with these things. LS is to list all the files which were present in the Raspberry Pi. So if I want to create a directory, make directory, all those things, okay. Now, we will run the piece of code over here and we will see in the cloud, okay. Python DHT11. If you want to run any code, you need to mention Python to it. Python txt.py. And one more thing, we need to write that API code which we need to push the data into the cloud. Okay, so I have mentioned that. Okay, we will take that write API from the ThinkSpeak channel. Okay, my channels, and for Raspberry Pi we have created VNR channel. Okay, from the VNR channel, I'm going to take the API key, the right API key, which I need to post the data over here. Okay, see, let me clear the fields first. Okay, I have cleared the channel. That means there is no data present in this channel right now. Okay, there is no data. Now I am going to Raspberry Pi. Okay, and I am going to I'm going to execute it with the right API. Okay, so when I execute this code with the right API, it says starting the sensor, and we will get the humidity and temperature value, and that temperature value will be sent to the cloud. Taking time because of this network. Yes, I have connected to the same network. Yes, but it is saying humidity and temperature none. Just wait, let me check with the interfacing of sensor. Let me restart the code. It's in the root. Just wait for 1 minute. Let us check this. So it's showing the temperature none value. See, the temperature value which we are getting over here will be displayed into our ThinkSpeak channel over here. So there may be a small maybe network issue over here. So likewise, see, we can straight away connect to the Raspberry Pi from virtually into the system and we can work. Let me again check this. Python commit underscore dht.py and we need to have the right. So let's check for one more time and let's see. Maybe so it will the same similar if the data that is present over there will come to this. So I'm turning off the Raspberry Pi. Okay, so that data will be coming to this temperature and humidity value. Okay, so this is what. Okay, so like this, you will get the data. You will get the data in the ThinkSpeak channel. Okay, so thank you. So any queries?
No, sir, we don't have any questions. The session was informative enough. It was clear. So, thank you for the session, sir. I mean, Arduino and Raspberry Pi are like the basic prototyping requirements for any student, and you've explained them really clearly. And all the information you've told is actually enough for starting a project for any person. So, we would like to present a virtual memento. Thank you, sir.